This is lesson 23, part 3, and we'll be continuing our discussion of compound time. The time signature is chosen by the composer and will be found on the leftmost side of the staff to the right of the clef sign and other important decoding information. The top number of the time signature will tell us how many beats there will be in each measure, and the bottom number will tell us what kind of note value will be our beat or pulse note. Remember that one way we can categorize time signatures is by their beat pattern, or in other words, how many beats per measure they contain. So duple meters will contain 2 big beats per measure, triple meters will contain 3 beats per measure, and quadruple meters or quadruple time will contain 4 beats per measure. Another way we can categorize time signatures is by their quality. 2 of the most common qualities we talk about are simple time and compound time. In simple meters, a basic note value, in other words, an undotted note value, is designated as the beat or pulse note. What defines simple time signatures is that because the beat or pulse note is an undotted note value, the beat naturally divides into 2 equal parts. Pieces or songs written in simple meter will have an even feel to them. If you feel as if you would be able to walk, run, or march to a song or piece, it is likely that it is written in simple time or simple meter. Some examples of songs written in simple meter or simple time would include Joy to the World, Angels We Have Heard on High, Old MacDonald Had a Farm. In simple meters, guitarists will need to play a straight strum pattern. Simple time signatures will always have a 2, a 3, or a 4 as their top number. In simple time, we can take the time signature at face value. So if the top number is a 3, we can know there will be 3 beats in a measure. And if the bottom number is a 4, we can know that the quarter note is our beat or pulse note. In compound meters, a dotted note value will be our big beat or pulse note. What defines compound meters is that because this big beat is a dotted note value, it will naturally divide into 3 equal parts or little beats. Note that this little beat will always be a basic note value, in other words, an undotted note value. Pieces or songs written in compound meter will have an uneven feel. If you feel as if you might be able to rock, swing, or gallop to the beat of a song or piece, it's likely it's written in compound meter. Some examples of songs written in compound meter would include What Child Is This?, Silent Night, and Hickory Dickory Dock. In compound meters, guitarists will need to use a swung strum pattern. Compound time signatures will always have a 6, a 9, or a 12 as their top number. In compound meters, the top number of the time signature tells us how many subdivided or little beats will be in each measure. The bottom number will tell us which note value will be our subdivided or little beat or pulse note. From there, we can do the math to figure out which dotted note value will be our big beat or pulse note.
Let's take some time to review our simple meters. So recall that simple meters are first of all defined by the fact that the top number of a simple meter will be either a 2, a 3, or a 4. So if we just glance over here at the compound meters, we can see right away that these meters have a 6, a 9, or a 12 as the top number and rule out that they could possibly be examples of simple meters. Recall that the other defining characteristic of a simple meter is that the beat or pulse note naturally divides into 2 equal parts. So if we look, for example, at this 2/2 time signature, the top number tells us that there are 2 beats per measure. And this is why we're classifying it as an example of simple duple meter. And the bottom number tells us that a half note is our beat or pulse note. Note that a half note naturally divides into 2 equal parts, which would be quarter notes. 3/8 is an example of simple triple meter. We know this because First of all, the top number is a 2, a 3, or a 4. So we have the 3 is the top number. Therefore, we know it's going to be a simple meter. And we know it's a triple meter because the top number tells us there will be 3 beats per measure. The other reason we know this qualifies as a simple meter is because the bottom number tells us that an eighth note is our beat or pulse note, and that eighth note naturally divides into 2 equal parts, which would be 16th notes. For 4 time is an example of simple quadruple meter. Again, we know it's simple time because the top number of the time signature is a 2, 3, or 4. We know it's quadruple time because the top number tells us that there will be 4 beats per measure. And we also know it is simple time because the bottom number tells us that a quarter note will be our beat or pulse note. And that quarter note naturally divides into 2 equal parts, which would be eighth notes. Now let's go ahead and look at our compound meters. So first of all, we know we can define these as compound meters because each of them contain either a 6, a 9, or a 12 as their top number. Notice that 2 times 3 equals 6. 2 big beats with 3 little beats inside each of those big beats equals a total of 6 little beats. So we can see the relationship between simple duple time and simple compound time. They each share in common that they have 2 big beats per measure. 3 times 3 equals 9. 3 big beats with 3 little beats inside each of those big beats equals a total of 9 little beats per measure. Again, you can see the relationship between simple triple time and compound triple time. 4 times 3 equals 12. 4 big beats per measure times 3 little beats inside each of those big beats for a total of 12 little beats per measure. You can see the relationship between simple quadruple and compound quadruple time. In addition to having a 6, a 9, or a 12 as the top number of their time signatures, all of these compound meters will also have a dotted note value as their big beat or pulse note. When we look at the time signatures of these compound meters, we can't obviously see what that dotted note value is. In order to figure that out, we're going to need to do an extra layer of decoding work when we look at compound time signatures. So let's work through this using 6 4 time as an example. The top number of this time signature tells us that there are 6 little beats per measure. And the bottom number tells us that a quarter note is going to be our little beat or pulse note. From there, we can figure out what our dotted note value or big beat or pulse note will be. So we have 6 quarter note beats per measure, and we know that in compound meter, the big or dotted note value pulse will naturally divide into 3 equal parts. So what note value will we get if we group 3 of these quarter notes together? Well, 2 quarter notes will give us a half note. And if we add a dot to that, the dot is worth half of whichever note value it's dotting. That'll account for the other quarter note. So in 6 4 time, our dotted half note will be our big beat or pulse note. Let's look at 9 8 time as an example of compound triple meter. Because it's a compound meter, we'll need to do an extra layer of decoding work when we look at this time signature in order to figure out what our dotted note value or big pulse note will be. So the 9 will tell us that we'll have 9 little beats per measure. And the bottom number will tell us that an eighth note will be our little beat or pulse note. So let's just draw that out over here. So we have 9 eighth notes, and we know that in compound meters, the big beat or the dotted note value beat will naturally divide into 3 equal parts. 2 eighth notes will equal a quarter note, and if we add a dot to that quarter note, it will naturally divide into 3 equal eighth notes. So, in 9/8 time, our big beat or pulse note will be a dotted quarter note. 12/8 time is an example of compound quadruple meter because the top number is a 12, and because the big beat or pulse note will be a dotted note value that will naturally divide into 3 equal parts. The 12 tells us that there are 12 little beats per measure, and the bottom number tells us that an eighth note will be our little beat or pulse note. So we can draw out 12 eighth notes. Remember that these are our little beats. In compound meter, we know that our big beat or pulse note, which is our dotted note value, will naturally divide into 3 equal parts. 2 eighth notes would give us a quarter note, and if we add a dot to it, that'll account for the 3rd eighth note. So our big beat or pulse note, our dotted note value pulse note in 12/8 time is going to be a dotted quarter note. This is an example of quadruple compound meter because there are 4 big dotted note beats per measure. Let's look at an example of how we might go about decoding a rhythm written in 6/8 time. First of all, we know this is a compound meter because the top number of the time signature is a 6, a 9, or a 12. Therefore, I'm going to know that the time signature is actually giving us information about the subdivided or little beat or pulse note. The top number tells us there will be 6 little beats per measure, and the bottom number tells us that an eighth note will be our little beat or pulse note. Instead of going to a note value pyramid right now, I'm actually just going to go ahead and try to figure out what our dotted note value or big pulse note will be. I've drawn out 6 eighth notes. I know that in compound time signatures, our big beat or pulse note will be a dotted note value. And I can know that since 2 eighth notes equal a quarter note, if I add a dot to that, it will account for our 3 eighth notes that our big beat or pulse note evenly divides into. So we can know that our big beat or pulse note, our dotted note value in 6/8 time, is a dotted quarter note. Therefore, we are going to call this single beat or pulse note do. Recall that we use the syllables do, da, di to refer to a beat that we evenly divide into 3 equal parts where each syllable represents just 1/3 of a beat. So for each set of these triplet eighth notes, we're going to use the syllables do, da, di. So let's set the metronome at 60, and we're going to put the beat into our hands or feet just as we have when we are reading examples in simple meter. Ready, clap. Ready, speak. Do, 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 da, dee, do, 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 da, dee, do, do. Feel free to repeat this as many times as needed, to slow down the metronome if this is too fast for you, or to even turn it off for now and just try to do this with as stable and steady a beat as you can muster on your own to take some of the time pressure off.